All right, so today we are going to be, we're going to be taking a look at section 2.5, okay? There's sort of good news and bad news with 2.5. The good news is that it gives you a chance to review a lot of the strategies from last week, okay? Meaning that our primary goal today is to transform things that look different from last week into forms from last week, okay? So that's sort of the good news. The good news is if you feel pretty confident about what we did last week and the decision making, then this week we are just sort of layering on the idea of maybe it's not always in the most perfect form, but how do we maneuver it so that it looks like something that we learned last week, and we can use techniques from last week to solve those differential equations, okay? So that's the good news. The bad news is if last week didn't go so well for you, it might feel like we're just kind of doing it all again, but it's harder and longer, okay? So either way, though, however you feel about it right now, I think that 2.5 was a great chance to kind of pause and refresh on last week and see where you might have questions, especially since we have our first exam coming up in just about a week. So being able to identify all of these different types of equations and then figure out how we use algebra to our benefit is actually going to be a really valuable skill, okay? And so, as usual, we have our growing list of what we know, okay? And so we have our what do solutions look like? We won't go too much in depth with that. I just want us to understand that we have a lot of different curves to choose from, and that when we have initial conditions, what we're saying is we would like to choose a specific one of those curves, okay? We've talked about basic integration formulas, good old friend U sub, okay? We're rarely going to do questions that don't have some sort of integration formula like U sub or integration by parts. For our integration by parts, I thought folks did a great job of describing the process in the discussion, but I also want to encourage us to think about how we know which one is our U and which one is our DV without sort of an internet resource telling us, okay? And then partial fractions, we haven't spent quite so much time on, but I think we will start to see that more and more. And by the end of this class, you may have a love or a hate for partial fractions. It sort of goes one of both ways, but partial fractions will be something that will be coming up more and more. So if that's something that you don't quite remember as much, it might be something that in all of your spare time, you start to sort of do a little bit of practice on, okay? But last week we focused on three main types of differential equations. We took a look at linear ones, we took a look at oh my gosh, we took a look at separable ones, we took a look at linear ones, and we took a look at exact ones, all right? And one of the questions that I did ask you in the homework assignment from week 1 was to make sure that we can sort of explain why we've chosen the ones we've chosen. Okay, so I think that's going to be an important piece to things, and I would expect that on our exam next week, it is entirely possible that I will ask you to tell me what method you may use and explain that. There will be some solving, but knowing that differential equations kind of take a long time to solve, I'm also going to be asking for that strategy, okay? So as you study, it's not necessarily just about can I solve the equation, but also about that decision-making process, okay? Now, what's new for today is, again, that transformation. And we're going to be transforming things using a lot of substitution. So substitution will help us transform the differential equation, okay? So we're going to do, today will be primarily a lot of examples, all right? So we'll go through these examples. These examples are going to start to become longer than last week. But again, I think they give us a chance to review some of those techniques from last week as well, all right? So let's take a look at this first category, solving a homogeneous differential equation. Okay. So we learned a lot of vocabulary in the past week, and this word homogeneous is going to come up quite a bit, right? So if you ever take a differential equation course beyond this one, homogeneous is at its simplest, means that you have this differential equation and it equals 0. Okay, so at the very fundamental definition of it, we have a homogeneous equation when we have something dx, something dy equals 0. Okay. Now, in our textbook, they talk about maybe some more specific types of homogeneous functions. And so we'll kind of layer in that vocabulary as we solve. Okay. And so when we look at this particular equation, which of the 3 techniques from last week, we learned separable, linear, and exact, which one of those kind of come to mind here, if any? Right, we have one for exact, maybe it seems like an exact one. Or maybe linear, okay. So I could see an argument for both, that we have sort of something, this is like our M or our N, and one might argue that it's going to be exact. And we have a test for that, right? So we can test to say MXY, or sorry, phi sub xy equals phi of yx. And so using that idea of partial derivatives to help us check. All right, we could also maybe see that it is linear, all right? So maybe by dividing by some things, we could do that, all right? So it turns out that in this case, what we're going to be doing is doing a little bit of substitution, okay? And so what we're going to do here is we're actually going to go ahead and see what degree our M and N functions are. Okay, so we take a look at this M equation. We see x squared plus y squared, and the highest degree here is 2, right? So we can actually say specifically that M is a second degree, right? And similarly, we can say that N is also a second degree, because in both cases, that highest power is 2, okay? Now, there's sort of a lot of different ways that we can substitute. And so it's important to kind of think about what we might want to use, all right? And so without too much more detail, let me tell you that we're going to be looking primarily for ratios of y over x, right? So when we are approaching these kinds of problems, we're going to be looking for ratios of y over x. And so sometimes they're very visible, but sometimes, like right now, they're sort of disguised. And what we need to do is some algebraic manipulation to go ahead and find those ratios, make those ratios very visible, okay? So in our first step here, what we're going to do with this differential equation is we're going to go ahead and divide by x squared, okay? And we're also going to divide by dx. Okay, so we're going to take our equation. We're going to divide by x squared and dx in every single thing, and let's see what we get. So when I divide, the x squared, this term is going to go to 1. And this term is going to become y squared over x squared. Now, as soon as I've said y squared over x squared, now we're like, oh, maybe we can start to see these ratios of y over x, okay? So I divide, I get 1 plus, and I'm actually going to write this as y over x squared. Okay, so instead of y squared over x squared, let's write it as y over x squared. And the dx, when I divide everything by dx as well, that dx goes to 1. Okay. Now, I don't just divide this first term, though. I got to divide everything. So now I move to this, and if I divide that by x squared dx, then I'm going to get 1 minus, ooh, there's that ratio again, y over x. And when I take dy and I divide it by dx, I get y prime. Okay. And the nice thing about having a homogeneous differential equation is all these manipulations, they change the left-hand side into a form that maybe we're looking for. But because the right-hand side equals 0, that still stays 0. Okay. All right, so I've divided through, and now I'm going to make a substitution. Okay, I'm going to say let's sub everywhere we see y over x, I'm going to replace that with the letter v. Okay, so everywhere I see y over x, I'm going to replace it with v. Now, thank goodness I wrote this as y over x squared, because when I make this substitution, right, I have a v is going to go here, a v is going to go here. And so I'll end up with 1 plus v squared plus 1 minus v. Okay. But when I make a substitution, I would really like for everything to be with v's and not with y's. Okay. How might I get rid of this y prime? Or how might I rewrite this y prime?
dv.
Okay, I think we're in the right track. I think we can use this expression to help us find our v, our replacement for y prime. But maybe what we can do first is say y equals xv. Okay, and now when we take a derivative, y prime equals, ooh, we better use our product rule on the side. Okay, so we'll get 1 times v plus xv prime. All right. Now, if we had kept it like this and taken a derivative, we would have had to use quotient rule. All right. We can't just take a derivative of the top and the bottom and then just call it day. We would still have to go back to the lovely quotient rule that we learned in Calc 1. But for here, if we multiply that over, it just makes it a little easier to take the derivative because we can use product rule instead of quotient rule. Okay. So what that means is everywhere I see a y, oh gosh, everywhere I see a y prime, instead of y prime, I'm going to write this expression, v plus xv prime. V plus xv prime equals 0. All right, so I've gone ahead and I've made my substitution. And now what we're going to do is we're going to do a lot of algebra. Okay, so we're going to simplify a whole bunch and let's see what we get. So this part looks fine, but in order to simplify this second part, I better remember that I need to distribute everything, or maybe think of that word FOIL, right? I have to make sure I take care of all 4 terms. So first, outer, inner, last, and let's see what we get. 1 plus v squared plus v plus xv prime minus v squared minus xv prime equals 0. All right, so I've substituted, I've distributed, and now I might see that this v squared, this plus v squared and this minus v squared, well, those cancel out, which is nice. And I'm left with 1 plus v plus xv prime minus xv prime equals 0. Right. Now, let me ask you that same question I asked you earlier, which is, what technique from last week do you think might be helpful in solving this differential equation? All right, so we've got our separable, our linear, our exact. Okay, maybe linear. Okay. Well, I think sometimes we don't always know, like sometimes it's the more of these we do, the more we'll be able to see, but sometimes we need to write out a few more steps before we can kind of see. And so I'm wondering if maybe what we can do right now is think about v prime being like dv dx and seeing if we can do something with that, okay? So let's see, I have 1 plus v plus x dv dx minus xv dv dx equals 0.
Judy, could we take the like say x minus xv and then that multiplied by dv dx and then take everything to the other side?
Like this clump of terms?
Yeah, so like you get dv divided by dx is equal to like -1 minus v divided by x minus vx.
Okay, so let's sort of unpack what you said, but I think that's definitely headed in the right direction. Okay. So I noticed that these terms over here, they have the dx on the bottom, and so maybe what we can do is sort of multiply everything through by our or not multiply. Let's go ahead and figure out if we can take these, move them to the other side, and see what happens. Okay. So 1 plus v equals, let's be careful here, xv dv dx minus x dv dx. All right. Now, one thing I noticed is both of the terms, yes, they both have dv dx, but you know what they also have? They also have an x. And so what I'm going to do here is I'm going to say we have 1 plus v, and I'm going to bring that x to the front. And I'll be left with v dv dx minus dv dx. Right. Now, maybe this is something that I could separate. Meaning if I can clump all of my x dx's together and all of my v dv's together, then I can use perhaps the most straightforward of all those techniques and go ahead and separate my variables. Okay. So let's see. I could actually factor this out maybe even a little bit more. 1 plus v equals x times v minus 1 times dv dx. Well, if I want to separate, let me take my v minus 1, and I'm going to go ahead and divide that over to the other side. Right. So one of the things that folks were really great about identifying in that discussion, the discussion number 2, is like, how do you know when to use a separable? Well, if everything is multiplied together, we can separate things. Right. Now, I don't like having the dx on the bottom, so I'm going to multiply both sides by dx. But since the dx will be on the left, I'm also going to divide this x to the other side. So I'm going to have 1 over x dx equals, I want all my v's on that side. So I'm going to go ahead and divide that to the other side. So v minus 1 over 1 plus v dv. Now, it is completely fair to be sitting here right now being like, but how did you even know how to do that, right? And so to sort of answer that question kind of goes back to this idea of ratios. If we can find these ratios of y over x, what that allows us to do is make some substitutions. So if we have these substitutions, now we can turn something that looks like it might be linear, but it's not linear because I have like an x squared and a y squared. And it might be exact, I don't know, we didn't try that technique, right? We didn't test for it, but it allows us to do some algebra so that the differential equation part is actually a little bit more straightforward, okay? Meaning the integration part is a little bit more straightforward. So we've done all of this work, right? And we're going to go ahead and start integrating now. And the reason why I can start to integrate is now I've got my x dx's on one side and my v dv's on another side, okay? So let's go ahead and integrate, all right? So I have the integral of 1 over x dx equals the integral of v minus 1 over 1 plus v dv. Okay. Now for the left-hand side, I hope we look at this and we're like, thank goodness, that is just a natural log, right? I don't know if you ever thought you would see the day where you're like, oh, that's just natural log. Natural log of x, okay? Now, we do have to figure out this other side, okay? And in fact, to integrate that, what ideas do we have? We could use a u sub, yeah. And what would you call your u?
V plus 1.
Okay, so if we let this denominator equal u, let's see what happens. Oh, perfect, there's room up here. So u equals 1 plus v, then du would equal dv. Okay, so that's kind of nice. How do we express v minus 1 though? Because we want everything in terms of u.
Is it possible to factor a -1 out of it and turn it into? Oh no, never mind. That wouldn't work. Sorry.
Yeah, no, I like your thinking though. It's like, how can we sort of manipulate things? And we can actually go back to our U and manipulate this. So if I want to turn 1 plus V into V minus 1, I could do that by subtracting 2, right? 1 plus V minus 2 gives me V minus 1. But if I subtract 2 from one side, I'll have to subtract 2 from the other side. So I could do U minus 2. So U minus 2 equals 1 plus V minus 2, right? So that same idea from like elementary or middle school, that if I do something to one side, I have to do it to the other side to keep things balanced, right? So if I go ahead and subtract 2, and then I simplify, U minus 2 equals V minus 1, that allows me to go ahead and put U minus 2 in for the V minus 1. And we've also made, everywhere I see a 1 plus V, I can put a U. So what do we get? The integral of U minus 2 over U du. All right. Now this might still seem like, oh, it's not that great, but what this allows us to do is actually split this into 2 fractions, or we could write this in 2 terms. So the integral of U over U, which is 1, minus the integral of 2 over U. And that is a lot easier for us to find that integral. Okay. Integral of that left-hand side gets us U minus 2 natural log of U plus C. All right, so the integral part, the actual differential equations part, is kind of right here, like all 3 of these lines. But in order to get there, we had a lot of setup to do, right? We had a lot of algebra to kind of make it into this separable piece. Now, I would say the most common mistake here is that folks take a look at this and they're like, I integrated, I'm done. But we always have to think about what variables our question was asked in, and we have to answer our question with the same variable. Okay, so we're not done until we substitute everything back in and we have X's and Y's in our equation. Okay, so what might that last step look like? So put back in terms of X and Y. All right, so don't forget that part, but we're going to go ahead. We have some U's, and we could turn the U's back into V's. But then we have to take the V's and put them back into X over Y, or sorry, Y over X. Okay, so we sort of have like 2 substitutions to unpack. Now, I do want to say something in terms of the homework that I took a look at this weekend. Some of you were incredibly thorough in showing your thinking, like showing me how you get from here to here. And some of you had some very magical answers. And I just wanted to make sure that you're aware that magical answers will not receive credit. All right, so if you were magically answering things or putting things on scratch paper, like I do want to see that work. I do want to see the U substitution, the manipulation. How did you get that? Okay. So make sure that you are documenting that for yourself, and that you are also, think of your homework almost as like you are trying to convince some skeptical mathematician that you know what you're doing. And so in order to do that, you need to show these steps. Okay. So let's do our substitutions, finish up this problem. The natural log of X, that can stay, because that already has an X. The U, now, everywhere I see the u, I'm going to put 1 plus v. All right, so 1 plus v, that was my u, minus 2 natural log of 1 plus v. And again, that was my u, plus c. All right, so we've got everything in terms of v. The last substitution is the yellow. Everywhere we see a v, we want to put y over x. And so we'll get natural log of x equals 1 plus y over x minus 2 natural log of 1 plus y over x plus c. And I don't know about you, but I'm all set. I don't need to turn this into a explicit solution, right? We already did so much work. If you did all this substitution, I believe in your algebra skills. You have convinced me. You can 100% leave this in this form. Okay. So let me pause here for a moment. We've just spent like almost a half an hour on one problem. What kind of questions do we have, if any, right now, before we move on and try?
I have a question.
Yeah, what's up?
So the first step, you say divide by x squared and dx. Where does that was just randomly assigned? Like, where does that come from?
That's
or is
a
that
really
always
great
guaranteed for every?
So we start with this idea that we want to find ratios of y over x. And so how do we do that? Well, if we have a y squared, if I divide by x squared, then I'll get y over x squared.
Mm-hmm.
Similarly, if I take this xy and I divide by x squared, I get y over x. And so we almost start by saying, I want to make these ratios pop out. How do I do that?
Okay.
Great.
Gotcha.
Question.
Thank you.
Oops. All right. Any other questions right now? And it is totally fine if you have questions later. I would completely understand if you had questions later. All right. Well, let's go ahead and move on to example 2, because I think that might also help us address this question of like, how do we know what we're dividing by? Because it is situational. We won't always be dividing by the same thing, right? So let's practice that decision making. All right, so we have example 2 here. We have y prime plus 4x squared plus y squared equals 0. Now, what would you want to divide by to create these ratios of y over x? Right, and that's a tough question. But as I sort of look at this, I'm like, well, I have a y squared here, right? And so if we divide by x squared, like David suggests, well, that'll turn into a y squared over x squared. That's good. What's going to happen to this term if we divide by x squared? It's just going to be a 4. And if we divide by x squared here, do we get a y over x ratio? And I think we can see that that's going to pop out. Okay, so let's divide by x squared in this case. And that will give us y over x, y prime, plus 4 plus y over x squared equals, thank goodness it equals 0, because we don't have to worry about any manipulation on the other side. Okay. Once we have substituted, we want to make sure that we are, or since once we divide it, we want to make sure that we are substituting. So we're going to sub in everywhere we see a y over x. We're going to substitute that with a v. And while we're here, we could write y as xv. And we can know that when we take our derivative, we're going to need that product rule in order to make a full substitution, okay? I'm going to do this substitution, but then I'm going to come back and show you sort of an alternate way to set this up in case you're like, oh, I don't really know what I'm supposed to divide by, okay? So once we sub this in, let's see what we get. Let's see, we chose yellow for that. So y over x will become v. And so we're going to get v. And instead of y prime, I'm going to write v plus xv prime plus 4 plus v squared equals 0. Okay. So once we divide by x squared and then we make our substitution, we get something like this, which turns out this is going to be separable. Okay. Alternatively, some folks like to substitute first and then divide away. Okay, so this right-hand side of the squiggly will be like another way that you could approach steps 1 and 2. Some people, they like to sub in first. And in particular, they have y over x equals v, and they sub in everywhere they see a y, they sub in xv. Okay. And then they deal with what are you going to divide by afterwards. And so if we make that substitution first, what we get in our original differential equation is we get x. Instead of y, we're going to write xv plus 4x squared plus, instead of y squared, we're going to write x squared v squared equals 0. Right? So some people like to do the substitution first, and then they think, okay, well, how am I going to, oh, I didn't sub in the y prime, hold on. Yeah, thank you. So that was our x, y, and then y prime. Together, okay? So you sub in everything, and then people are like, well, what do I need to divide by to kind of clean that up? And if we divide by x squared in this step, then we'll get to the same differential equation we have on the other side, okay? So divide by x squared, and that will give us v squared plus xv prime plus 4 plus v squared equals 0. Right? And so if we look at this step right here, if I distribute the v and v, I'll get this v squared. And if I distribute the v to the xv prime, I'll get xv prime. Right? So you can switch the order here. I would practice a couple and see what you like better. If you're like, it's easier for me to think about what I want to divide by to get that ratio, do that first. But if you're like, well, I just want to substitute and then manipulate it after, you can also do that. Okay. Now, either way, what we end up with is a separable differential equation. All right, so let's move some things around and let's see what we get. And so without loss of generality, I'm going to look at the left-hand side here. Okay, so I have v squared plus v squared, 2v squared plus xv prime plus 4 equals 0. I'm gonna subtract the v squared to the other side and the 4. And so I'll get x v prime equals negative 2v squared minus 4. But you could also subtract the x v prime. That would be fine as well. And I note that v prime I could write as dv dx, right? So I could go ahead and multiply both sides by our dx. So let me write that out. So if I multiply both sides by dx, that means I'm trying to collect my x's, dx's on the right-hand side. A little bit more manipulation. I'm going to divide both sides by the x so that I can get all my x dx's on the right-hand side. I'm also going to divide both sides by this negative 2v squared minus 4 so I can get all my v dv's on the right-hand side or on the left-hand side. And so what do we end up with? V over negative 2v squared, oh gosh, 2v squared minus 4 dv equals 1 over x dx. I'll give you a moment to kind of catch up. I know there's a lot of writing here. Now, everyone's going to have sort of a personal flavor that they like. And so one thing that folks might be looking at that make them uncomfortable is like, oh, there's a lot of negative signs on this left-hand side. And so some people might choose to sort of factor out a -1 on this side and then move that -1 to the other side. That's absolutely fine. Whatever sort of makes you feel a little bit better about the integration that we're about to do, okay? All right. Either way, we can move the negative sign or we can keep it. I'm going to keep it for today, but again, you're welcome to move it if you want to. I think the right-hand side is very clear. When we integrate, we're going to get that natural log of x. And I'm wondering for the left-hand side, what technique do you think we should use here? Because we have a lot of techniques to choose from for our integrals. What are we thinking?
Can you do U substitution again?
We can indeed. All right, so U substitution, just like seeing if things are separable or not, is a really good place to try first, right? Some of us might look at this denominator and be like, oh, I don't know, maybe it's like an inverse trig, or we might start to panic and do more than we need to. But I would encourage you to start with the fundamentals. U sub takes you a really long way. So does this idea of separable equation, okay? And so we are indeed going to use U sub over here. And let's maybe set up our u would equal negative 2v squared minus 4. Du would equal negative 4v dv. And so in order to match the v dv that's there, I need to divide away that negative 4. So let's make that substitution on the other side, and we will end up with a, let's see, negative 1/4 the integral of 1 over u du, which is going to equal the integral of 1 over x dx. And when we take our integral of both sides, we'll end up with negative 1/4 natural log of u equals natural log of x plus c. Now, I did notice that there were a handful of people who were forgetting that plus c, and it's so very important that you have that plus c there. If you don't have the plus c and you have initial conditions, you don't really have anything to solve for, okay? So let's go ahead and make sure that we have that plus c there. Now, again, we've done our integration. We solved the differential equation, except we have to unpack it. We got to put in everywhere we should have x's and y's, no more u's, no more v's, okay? And so if we take our integration or our substitution step by step, let's see what we get. We end up with negative 1/4 natural log of negative 2v squared minus 4 equals natural log of x plus c. And I'm going to put in my v's back into y over x. And I'll leave that up to you when you sort of want to do this. Some people like to go ahead and exponentiate both sides, so e to the power of both sides, so that we can get rid of the natural logs, and that is absolutely fine. And if we wanted to do that, what might work out here is, let's do a couple of things. This negative, I'm going to put that on the other side. Okay. The reason being, I can take the 1/4 and I can move that up as the power for my natural log, right? One of those natural log properties. But if I'm putting it up as a power, I'd rather just have either fraction or a negative. I'd rather not worry about both. Okay. And so if I do that, I'll end up with natural log of negative 2v squared minus 4 to the power of 1/4 equals negative natural log of x plus c. And then I can exponentiate both sides, meaning e to the power of both sides, and I will end up with negative 2v squared minus 4 to the 1/4 equals x to the negative 1 times c. Now, I'm sort of pausing here on purpose because this part, this simplification part, I noticed that there were definitely more than a handful of people who kept this as a plus sign in between. So they did like e to this power plus e to that power. And algebraically, that's really not where we're going, because we have e to this whole thing. And when we split our exponents, we actually have to multiply those. Okay, so it should become a times c and not a plus c. Okay. Last thing we need to do, we really just need to get rid of that v. We're going to put back in that y and that x. And so we'll get negative 2 y squared over x squared minus 4 to the 1/4 equals c over x. And you're welcome to go beyond this point if you want. You're also welcome to say, I'm all set. I would like to leave it this way because I already did so much work. Okay, so let me get that on one screen for you. I know we're doing like a ton of writing, so. Now you're going to find that there are different variations of like a final answer, and everyone sort of has their own flavor on how much they simplify or how much they don't simplify. So I'll kind of leave that up to a personal preference, but just make sure that you're leaving me enough breadcrumbs along the way so that I know that you are doing your U sub. I know if you're doing integration by parts, how you're setting that up. and things like that. Okay, I'm less concerned about that final answer. I'm more concerned about, do you know how to do all the steps to get there? If that makes sense. All right. So we have one more example of this type. Would that be helpful for us to do today? We'll just do one more example of this type with the homogeneous equations.
I think so, since we're already doing it right now. So just add on.
Yeah. Okay. All right. So let's take a look at example 3. Okay. Now with example 3, we've got xy prime equals y, natural log of x minus natural log of y, and we've got an initial condition. Okay, so what that means is at the end, we're not going to have a c, but rather we're going to have a numerical value for c. Okay. So what are our thoughts? Would we like to sort of divide by something first and then substitute, or would we like to substitute and then divide? Are folks feeling drawn to one way versus the other?
Kind of like the divide out first and then substitute.
So let's do this then. We'll take this left-hand strategy, we'll divide through first so we can practice deciding what we're going to divide by, then we'll make our substitution. Okay. All right, so. Oops. Now, one thing that might be helpful, since again, we're thinking, let me find ratios of y over x, is a lot of times if we see natural logs, even if we don't love logs, if we think about how we can sort of use the properties to our advantage, that might actually help with that decision making of like where we're going to substitute or what we're going to divide by. And so in particular, what's another way of writing natural log x minus natural log y?
Is that natural log x over natural log y?
Ooh,
Or
you're
is it
so
the
close.
other way around? Or is it the opposite way? Is it the y over the x?
Good question, good question. Let's put in a step 0.5, all right? And we are going to keep this as xy prime equals y. Now here's the thing, you are right that there's a division, and it turns out that it's the first one divided by the second one, okay? So it'll be x over y. However, we don't keep both natural logs. There's only one natural log, and it's gonna be natural log of the first one over the second one.
Okay, gotcha.
Okay, yeah. So we've got xy prime equals y, natural log of x over y. Okay. Now, I'm actually really glad that you said, let's try figuring out what we need to divide by, because we said earlier it's situational, but both the examples we did, we divided by x squared, right? So it didn't really seem to matter. What are our thoughts? What would be good to divide by here?
Could we divide by y?
We could divide by y, yeah. So I think dividing by y would be one option. And we could have x over y, y prime equals the natural log of x over y. Yeah. Another way, if you're like, well, this is x over y, and we've been using y over x, you could have said, I'm going to divide by x And then on this, oops, on this side, you would have y over x, right? So both of those ways would be fine, but let's kind of pursue this and see how far it takes us, okay? We're still going to sub in everywhere we see y over x, we're going to replace that with a v. We're going to note that we have to replace the y prime as well. And so product rule might be an easier rule to think of than quotient rule. And we obtain our v plus xv prime. All right. So let's go ahead and make those substitutions, being really careful. What are we going to put in for x over y?
1 over v.
You got it. We're going to put in 1 over v. Okay. So 1 over v. And instead of y prime, I have v plus xv prime and natural log of 1 over v. Okay. Now, again, the questions of this flavor tend to end in something separable. And so our goal now is to keep manipulating it until we can get all of our x dx's on one side and all of our v dv's on the other side, okay? So take a moment, maybe write out a few steps, see how far you can get, and then I'll start to fill in maybe the way I was thinking. But what I really like is what you guys are suggesting actually are different than what I have on my notes here, but there are a lot of different ways to approach that, right? And so I do want to respect that creativity in terms of how you think. I just want to make sure that you're documenting all those steps along the way, okay? So let's take a moment. Let's see how we might get all of our x's, dx's on one side and all of our v, dv's on the other side. Anyone got a couple steps that they'd like to share out in terms of strategy here? It's okay if you don't. I'm just wondering.
Oh, sorry, go ahead.
No, go for it.
I was just gonna say that I started by multiplying by v and then subtracting v from the right.
So multiplying by v to get rid of that one, and
Correct.
then subtracting this v away.
Correct.
Okay, let's try it. So that would give us xv prime equals v natural log of 1 over v minus v. Okay. I think from here, what might be good is to think about splitting that dv and the dx, right? We could start from there. So we have x dv equals v natural log of 1 over v minus v times dx. And I really like to root myself in where my dx is and where my dv is, because if those are not in the numerator, then we really can't integrate, right? So once we have those, then we can kind of tell what we need to bring to what side. And so what this tells me is I should divide both sides by the x and divide both sides by this big long v expression in the parentheses. And we'll end up with dv over v natural log of 1 over v minus v equals 1 over, I guess I should say, consistent dx over x. Okay. And so we've worked with a lot of the manipulation. This particular one, I think the right-hand side, super easy to integrate. We know that's going to be a natural log. Thank goodness for that. This one, however, looks worse than it is, okay? And so I think if we stick to our basics and think, all right, U sub has carried us this far, let's try a U sub and see what happens. That can be a great place for us to start for that step 3. Okay, so let's put a step 3 up here. And let's set up a U sub for this left-hand side over here. So one thing that might be useful is noticing that we actually have a common factor of v on the denominator. And therefore, that leaves us with natural log of 1 over v minus 1 on the interior. The nice thing about this, even though it looks really, really gross, is I can use a U sub here, right? And generally it's sort of like a Goldilocks situation. You don't want to pick too much as your U, you don't want to pick too little as your U. You want like sort of that sweet spot, right? Like a place where you have a U, but you can also substitute out a du. And so if we let U equal natural log of 1 over v minus 1, and we're taking derivatives. I know we're sort of going both ways here and it's very confusing sometimes, like, are we integrating, are we taking a derivative? But that 1 is going to go away when we take a derivative. And then to take my derivative of the natural log of 1 over v, natural log is 1 over whatever that is, times the derivative of the inside, because we do have to use chain rule here as well, which is going to be negative 1 over v squared. So I'll make a note here that we used chain rule. And if we clean this up, we will get negative v over v squared, which is shockingly close to this clump 1 over v dv. Okay. The only thing we have to account for is that negative sign. So we can go ahead and divide that out and replace our dv with a negative du. All right, I think we're ready to integrate. It turns out that our integral on the left-hand side is simply going to be negative the integral of 1 over u du. And our right-hand side, we have our integral of 1 over x dx. All right, so all that algebra in the beginning, we were able to turn this into a situation where the integral itself is not that bad, okay? Now, I don't want that to take away from the fact that you did a lot of work to get here, okay? So it's just sort of knowing we're going to do a lot of algebra and embracing that, but that's sort of the theme of differential equations. We're going to use a lot of algebra to make the derivatives and integrals way easier, okay? All right, let's take our integrals. And believe it or not, that's basically like our calculus step right there, for better or for worse. And then we just gotta substitute everything back in. We want our final answer to have x's. We want our final answer to have y's, so that we can use the xy initial condition. Okay. So we get negative natural log of, gosh, our u was so long, natural log of 1 over v minus 1 equals natural log of x plus c. Now we have to unpack slowly here, okay? I have two natural logs here. It doesn't become natural log squared, but rather I have to e both sides, not just once, but twice. The first time that will get rid of that one. The second time I will be able to get rid of the second ln, okay? Now, just like before, I don't want to deal with this negative sign on this side because I already have a lot to deal with. So I'm going to divide this negative sign to the other side. And I'm going to e both sides in the same step. So I have natural log of 1 over v minus 1 equals, let's see, what do we have? E to the natural log of x to the negative 1 plus, oops, plus c. All right, and so this time I'm actually showing you we've got that plus c in the exponent. And so when we split into our two parts, we'll have the first part here, but then it'll be times the second part because of our exponent rules. So we get natural log of 1 over v minus 1 equals, be careful here, c times 1 over x. And the 1 over x comes from that -1 exponent. And there are a couple people who missed that on the homework, all right? So I just wanted to point that out, not as a for shame, but just that that negative sign does actually change what that might be, all right? And so we'll end up with 1 over x here. And this c is really e to the c. And so that's why we're multiplying it there. And now we just have to get back into our v. So we're going to do one more time. Let's e both sides and see what we get.
Judy, why don't we keep the absolute value?
Great question. So are you referring to
Like to the ln and then absolute value of 1 divided by v minus 1.
oh, is it here?
Like, yeah, just in general there, like why we have it, why don't we have it in front of like the 1 divided by v minus 1?
Great question. So you'll look at this line right here, and you can see that we have natural log of absolute value on both sides. So when we get rid of that, we're still going to have plus minus on both sides.
Okay.
Right? So we're sort of absorbing it along the way, just like we're absorbing that c along the way, if that makes sense.
Right. Okay.
Okay. All right, so we need to get rid of this natural log, which means we have to e both sides again, right? That's an option. An alternative option, okay, and this comes down to sort of personal preference, is as long as you put your y over x back in for your v, you can put in your initial condition. All right, so if you're looking at this saying, I don't know, this is just a lot more algebra, at the end of the day, we want to find our c value, okay? And so at whatever stage you substitute in, you're going to get a certain c value, right? Because it continues to get absorbed along the way. And so if you're like checking your work with an answer key and you get a different c, it could just be because you substituted in earlier rather than later. But if you carried that through all the way, you would actually end up with the same c as somebody else who substituted in later. Okay. But let's for
Hey.
right now. Yes, go ahead.
Hey, is maybe I missed something, but is that ln of 1 over v minus 1? How does the 1 minus 1 go inside the parentheses there?
It doesn't. Thank you. There we go.
Oh, thank you.
Okay. All right.
Esther, sorry if I may just ask one question. Just going back to part 4, the second line. So when we divided the right-hand side by -1, so it made ln of x go to the -1 power.
Okay.
that what
Let me
it's-
write. Yes and no. Let me write that step out. So we divide that negative away, right? So we end up with this.
Yes.
Right? And then one of the exponent rules, or one of the log rules that we use a lot is whatever the coefficient is, we can bump it up as the power, right? And
Okay.
so we'll end up with
Okay. Thank you for that.
makes sense? Of course.
Yes.
I always forget, and I mean, I kind of get why we do this in the sequence we do, but like, when's the last time you saw this much algebra or calculus, right? It was like 3 classes ago, depending on when you took it. So yeah, it's sort of a nasty like way to send you off. It's like, surprise, all that calculus and algebra coming back at you after like working with matrices and other nice things, right? Okay, so there's that step right there.
Hey, Judy.
yeah.
I'm sorry, just one real quick. Above step 4, if we would have done this stuff there, could you have got rid of those ln's when it was still in terms of u and x and
Yeah,
save like
yeah.
a little bit? You get the same thing, right?
Yeah. So there's going to be, you could unpack here. You'd still have to unpack it again because you had that natural log in the u, but that might sort of split this into like 2 different steps and make it easier on the brain. That's absolutely fine. All right. So I think we can finish this problem in the last 8 minutes that we have. We're going to go ahead and thank you, Christian, for catching that mistake in my parentheses. We're going to add 1 to both sides. And then we're going to or exponentiate both sides to get rid of that natural log. Okay. So natural log of 1 over v equals c over x plus 1. And then I'm going to both sides. So I'll end up with 1 over v here and to the c over x plus 1. And now I'm ready to finally put back in my x over y, or my y over x. Okay, so I have 1 over v. I can replace that with x over y. Okay, so because I have a 1 over v, I'm going to replace it with the reciprocal of this, and I'll get x over y. So we'll get x over y equals to the c over x plus 1. Okay. And you can continue to simplify if you want, or because you have x's and y's, you can say, I am ready to plug in those initial conditions. Okay. And I think based on the amount of time we have left, we might be ready to plug in those initial conditions. So we're going to go ahead and put in a 1 everywhere we see an x and a 4 everywhere we see a y. So we will squeeze in a step 5 somehow. Let's see what we can do. Okay, so what did I say? 1 in for x, 4 in for y. So 1 in for x, 4 in for y, to the c over 1 plus 1. And so we'll get 1/4 equals e to the c plus 1. But I want to find c. So how do I get c out of the exponent? Well, I use logs. So I'm going to log both sides so that I can get rid of the exponent. And that will give me natural log of 1/4, which is c plus 1. And so c is natural log of 1/4 minus 1. Okay. Now, depending on where you might see answers from, you might not see natural log of 1/4. You might, in fact, see it as negative natural log of 4 minus 1. And the reason for that is they said, oh, natural log of 1/4 is natural log 1 minus natural log 4. So natural log 1/4 is equivalent to natural log 1 minus natural log 4. Natural log 1 is 0, so then we're left with negative natural log 4. Okay, so if you're checking with like other websites, that's an explanation of where they're getting that from.
Judy, for this one, was it okay if I continued to solve for y and I had like y equal to x times e to the negative c over x plus 1?
Mhm, yeah.
And plugged it in?
Mhm.
Yeah, okay.
Yeah.
Thank you.
Yep. Wherever you simplify to, just make sure that you're leaving me enough breadcrumbs along the way so that you're convincing me that you understand where these steps came from. Okay.
Mhm.
All right, let's write our final answer maybe down here because we want to go back to our equation, except everywhere we see the c, we're going to put in the value we found for c. And so that will give us x over y equals e to the negative natural log 4 minus 1 over x plus 1. This would be one form of an answer. Alternatively, you can find the reciprocal and solve for y. That is also fine. Okay. So get that question on one page for you. And we've squeaked in right under the buzzer. Definitely some long problems here, right? Which is why we're reserving 2 full days for 2.5, because it's a lot of algebra in conjunction with all the skills we learned last week. Okay. So that is where we are going to stop for today. If anybody has any questions, happy to stick around for a little bit. Otherwise, if you do not have questions, you are welcome to take off for the day. Okay. Have a great day, folks, and I will see you tomorrow.
Thank you, Professor.
Bye.